In this video, we are going to clarify the concept of pass by value and pass by reference using a small C++ demo program. So let us first define the prototype of prototype of a function like this: void change. The first parameter is just int I, just as you have done before. The second parameter, instead of passing just like normal float f, I am just preceding the f with an ampersand. Now this ampersand means it will actually pass the memory location. How can I say that? Let's see a small demo before going to the actual function calling code. So let us say that, okay, int f, or int let's call it float f, or whatever it is, you can give any name. So float f, and now let's say, and initialize it with a value of 10.33 or something like that, whatever. And now cout f. What should be the value of f? As you can all say by seeing the program, the print 10.33 will be printed on the screen. So let's see whether that happens or not. Okay, I forgot a semicolon over here. So now let us run it. So as you can see, 10.33 is being printed over here. So the value have been printed. Values stored inside f have been printed. Now, if I just use this ampersand, what should be the output? Let's see what it is. If I run this program, then you will see that, well, there is no error or something like that. Rather, it has printed a weird string of like 7FE980, something like that. What is this? This one is a memory location inside your RAM. And this is 0x, means this one is represented using another number system called hexadecimal. Hexadecimal is another number system similar to decimal, where we have like 16 different uh, digits or characters to express the number. So anyway, we are not going into the detail of hexadecimal number system, but this is just to show you that if I use ampersand before the variable name, it will give you the memory location, the actual memory location where where the variable f is stored. And we are going to utilize this feature of C++ to pass by reference. So now let's focus back onto our function. So let me get rid of this. So the function is like int I is the first variable, and float ampersand if we are actually passing the memory address of a variable here. So now let's see what happened. So let me write down return 0 over here, and now let us focus on the actual program. So here, let's say I take two variable, let's call it int x, and I am initializing it with 100, and then let's say I'm taking float y, and I'm initializing it with, say, 200.445, something like that. So these are two variable initialized. Now let us print these values. Cout the value, so it should be inside quote. So I'm printing it inside main. So let's write down clearly in main, and I did not call any function change or anything. So before calling change function, so the value of x, or let's call it just x equals, I'm printing the value of x, and the y equals the value of y. So let us run this program. As you can all understand, what should be the output? It should print in the main before calling change function, and then it will print x equals 100 and then y equals 200.445. So let's run it and let's see whether it is printing or not. Well, of course it is printing correctly. So the value of x is 100 and the value of y is 200.445. All right. Next, now let us define a function called change like this. So void change I and f. So here let us change the values like this. Let us change the value of I equals 20. I equals 20. And so after I equals 20, so I have changed the value of I to 20 here, and then let us change the value of f to 30.44469, something like that. So I have changed the value of I to 20 and f to 30.469, which are significantly different from 100 and 200.445. And once again, do not worry about the variable names over here. You can use any variable name. All that matters is the sequence, as I discussed in the previous demo video. So all right, now let us print the values. Cout. So let me just copy this, and here it is. So instead of x and y, I am just changing it with I and f like this. And now if I just call this function, let's say this change with x and y as argument. So here basically I am passing the value of x, passed by value. X is passed by value, but y is basically passed by reference. So now let us see what is happening. So here if I run this program, well, let me just print an endl to get everything in the same screen. Just a line break. So as you can see, so here still there is everything is predicted, right? So the first line is x equals 100 and then y equals 200.445, and then in the next line it came to this change function and it printed the value of I equals 20 and f equals 30.469. All right, so far everything is predictable. Now let us see what happens to this variable x and y after calling this change function. So let us see what happens. So now if I run this program, as you can see in here that the value of x remains same as before, but value of y have been changed from the previous one. Previously it was 200, but now it is changed to 30.469, which is being done inside this change function. And that happened because the second parameter, which is f, or which is mapped to y, the original memory address of this y variable have been passed, and the result is written in the original memory address, not on any copy. So pass by value remains unchanged even after execution of the function, but pass by reference means the value have been changed original. So one more thing that you should notice in this program, that for pass by reference you have to add this ampersand in the function prototype as well as in the function heading part. But when it comes to the function calling from the main or from other caller function, you really do not need to do anything. Here, as you can see, you pass to y just as a normal variable, but it worked as pass by reference because the prototype and the function heading have been changed.